So the problems at high frequency operation, we resort to the field concept. The circuit radiates and accepts radiation. The information is lost. Conductors become guides. Current flow becomes field flow. So EMI EMC problem is there. Source and victim. Links in circuit behave as distributed parameter. That means if you have a small wire to connect a resistor and an inductor, at low frequency it's only a wire, but that becomes a component at a high frequency, becoming a distributed parameter. The wires become transmission lines with characteristic impedance, skin effect, and delay. Delay leads to phase shift, and digital circuits have high frequency effects and high energy particle behavior, because as I already told, at high frequency the energy is quite high. So high frequency effects or skin effect, where the current tends to flow only in surface. Transit time, which is very important. Fourth point, delay is very, very important. And moving electron induction of current, retardation, phase reversal, displacement current, cavity effects. These are all high frequency effects which you will be studying while you deal with microwaves, or when you talk about optical fibers or antennas. So in high frequency, the fields inside the conductor is zero, but at low frequency, the energy is through the conductor. At high frequency, field is zero inside the conductor. Energy radiates from the conductor. So conductor no longer behaves as a simple conductor with R equal to zero. The conductor offers resistance, inductance, right? G is conductance and capacitance along its length. So the signal gets delayed or phase shifted. Why it gets phase shifted? Because the wavelength is very small and it is comparable to the dimensions of the conductors. Next, of course, we have the skin effect. So before going to the next thing, right, we will see the